Tonight we're going to look at lists. We're actually not covering tuples. That's towards the end of the chapter. Once again, we're not doing absolutely everything in this chapter. Lists and tuples are what are called sequences. Actually, a string is also a sequence because it's there's a series of characters, right? And you can do special things with sequences in Python. But the main thing that you need to know about lists, I've tried to put it right here in a document. So far, we've worked with variables frequently, right, almost from the outset, and a variable held one value. Well, now we're going to look at a data type that holds multiple values, a group of values. It's called a list. Most programming languages call something like this an array, but in Python it's called a list. So it's a group of values. It could be a group of integers, it could be a group of floats, it could be a group of strings, or it could be a combination of any of those, which is sort of unique to scripting languages, of which Python is one. Other languages like Java, for example, when you make a list, they have to be all of the same data type. You can't mix them up, but you can in Python. Most of the time, you're not going to do that, however. Another way you can think about a list is it's a single variable with multiple slots for values. So there's sort of two ways to look at it. The values in a list are called the elements of the list. So that's terminology that you'll see frequently in the textbook or in the readings. Now you can make lists of any of our types. The only types that we've been working with are ints, floats, and strings. I guess we've also used booleans, true and false. We could make a list of those too. But you can mix them up. Now here's an example of how you could create a list with square brackets. You could use a set of square brackets and a comma-separated list of elements. In this particular case, I have 7 ints. Notice the comma separators, that's a requirement, and the square brackets is also a requirement. So when Python sees those square brackets, Python says, aha, here's a list that I'm going to call nums. And a key point about this is that the elements are indexed numerically, starting from 0. And that's pretty common in all programming languages. The indexing starts at 0. So here's our nums list in the top row here, from 4 to 17. And the indexes go 0, 1, 2, 3, 4, 5, 6. 7 elements indexed from 0 to 6. That's an important concept to always keep in mind. Indexing starts at 0. So the third number is actually index 2. So you have to watch for that. Pardon me. Okay, so we've got a couple of sample programs to try with you. Here's one called lists1. And this is actually covered quite nicely in your textbook, how you can create lists. This is on page 344. It shows you several ways that you can make a list. You could do it with the square brackets like we did back on the Word document page, but you can also use the list function and the range function to very quickly make a list. Now, if you recall how range worked, this range is going to go from 10 up to 100. Remember that you never do get to this number here. It's always one less than that number. So this should go from 10 to 100 in increments of 10 or steps of 10. So I'm going to run this program right now. And what I'll do first of all is I'm just going to comment out the bottom part for a second. So I'll comment that out, which I can do very nicely with the format menu. And we'll just give this a run. And here's the output that I got from that. You can see that the list does go from 10 up to 100. But simply printing the name of the list, as here, is pretty crude. It just dumps the list out inside square brackets. It's not something you're ever really likely going to be asked to do in an application. It's a good thing to do as you're writing a program to see if your list actually holds what you think it does. You can see what's in the list very quickly. just by printing the name of the list. Usually what we want to do is we want to process a list with a loop. And loops and lists are made for each other. Programmers love working with lists and loops because you can so do to process a list called nums. As I go through the nums list, each element will be assigned to this variable n. So the first time through the loop, n is going to be 10. Next time through the loop, n is going to be 20, and so on. So this should print them all out on one line, which, as you can see, is what we got here. So it's just that easy to print out the elements in a list all in one line. You'll recall that the end operator cancels the new line that print normally generates. Any question about that? It's pretty cool what you could do. I went from 10 to 100 here, but I could change this. I could go from any start to any finish and any step as well. And if I took out the step, let's see what we get. I get from 10 all the way up to 100, all the way, right? Get a huge list. There it is, dumped out in the square brackets. And here it is, separated by spaces. So you can quickly get some numbers into your program with a list, which makes it excellent for things like statistics and numerical analysis. A lot of mathematical operations can be done quickly this way. Any questions at all about this one so far? No? Okay, good. All right. I'm going to bring back this part here, which I commented out by selecting Format, Uncomment Region. That brings it back. And let's see here. We're going to print out the fourth element in the list called nums. Now to do that, because indexing starts at 0, it's nums 3. I can change the value of any element simply by reassigning it using its index inside square brackets. Whenever you see the square brackets, that lets you know you're working with the list. So this means change the element with index 5. That should be the 6th one, by the way. We'll set it to 0. Now, as well as being able to process a list with a for loop, you can also use a while loop. And here we have a case in point. We've got to set the index initially to be 0. I'm using a variable called dex to represent the index of each element. And of course, that's got to start at 0. Well, I can say while dex is less than. Now here's that len function. The len function will automatically determine how many elements are in the list. So while dex is less than the length of the list, print nums dex. Here's the secret. We put the dex variable inside the square brackets. Because that's going to go from 0, 1, 2, 3, etc., all the way up until the end of the list. Now, when you're using a while loop, you have to remember to modify the value of dex. You have to add one onto it inside the loop. Let's see what this looks like if we run this program now. Okay, I'm going to take it back to being steps of 10, like it was back here. So I'm going to modify this slightly here and then run it again. And here's what it looks like. So the fourth element is 40. Yes, there it is. But notice to get it, we had to use index 3. And here's the output of the while loop. So you got to be careful with the while loop, though. If you forget this, I'll comment this line out. If you forget this line, something disastrous happens. Well, not really disastrous. Something that you don't want happens. Watch what happens when I run it now. You get an endless loop. The index didn't change. It continually prints index 0. And that's going to continue until my computer crashes or the power goes off or whatever. That is an endless loop, a common programming error. And while loops, you have to be careful. While loops can cause that. So you have to make sure that the index eventually gets up to the end of the index by adding 1 each time. Any question about that one? It's like a sort of a basic introduction to lists.
Just a little off topic on the while loops. Is there ever a situation or a use case where it's desirable for a loop that doesn't break, a loop that doesn't end?
To use a while loop instead of a for loop, you mean?
No, I mean when you remove the dex, add in 1 to the dex, it just became an infinite loop. Is there ever a use case for an infinite loop?
Yeah, you can do things like this, for example. You can make an infinite loop by design like this, and then you can stop the loop when some condition that you want to watch for occurs. Like you can watch for a sentinel value, and if you detect that, then you can use the break keyword to stop the loop. But it's not something that we've covered. So I'm going to go back to what we had earlier here. Yeah. Sometimes an endless loop by design is not a bad idea. Any other questions about this one before we carry on?
No, thank you.
Okay, I've got a few more examples to take a look at. So let's take a look at one called, I think we've got one called list 2. Open that up. There it is. Kill this one off here. And here's list 2. What we're going to see here is a list of strings. Here we have a list of pals. We've got 6 friends up here. And what we're going to look at here is how to use slicing. There's a technique called slicing that you can use to extract a sublist out of a list. It's called making a slice in Python. And you do it with square brackets and specifying indexes inside the square brackets and using a colon to separate the possible indexes that you want to use. So for example, if I want to make a new sublist called BFFs, and I want to slice out the friends at indexes 1 to 3, this would do it. Once again, it's 1 less than this is what you get. So from 1 to 3, that should be Penny to Kenny. Kenny is index 3, right? 0, 1, 2, 3. But the syntax that's required is 1:4. So what I'm going to do, once again, I'm just going to comment out the bottom part of this, and we'll run the top part here. And as you can see, we're going to run through the BFFs new list. We made a new list here by slicing out. We're extracting and getting a sublist called BFFs, and we're going to print those all out on one line. Hopefully, let's see what happens here. Yeah, we got Penny was number 1, and we wanted to get from Penny to Kenny, so we used 1:4 inside the square brackets, and then we went through the BFFs list, letting each one be BF. It's very important that you understand that concept there. BF takes the value of each element in the list 1 by 1 as the list, as the loop cycles. Okay, well, we've got, if you're okay with that, we've got some more to look at. So let's see if we can get that back up, and we'll make this part of the program come back with uncomment the region. And we'll look at some more slices that we can make out of the PALS list. All of this is covered very nicely in your textbook, by the way. But right here, 2 colon, if you leave off the last part of the, that's after the colon, that means go all the way to the end of the list. So that should go from index 2 to the end of the list. Well, index 2 is Jenny, so that should actually print these out all the way to the end of the list. If you leave out the first number before the colon, it's assumed to be 0. So this should be actually from 0 to 3, right? Remember, it's 1 less than this. So that should print out Lenny, Penny, and Jen. You can also use a negative number. This means start at 2 from the end of the list and go through to the end of the list. So that should print out these 2, Benny and Denny. -2 from the end of the list. and then finally, pardon me, you can actually put 3 numbers in. I'm going to leave off the middle number, and that means go all the way through the end of the list. So I'm going to start at index 1, and I'm going to put a step of 2. You can specify a step as well when you create your slice. So I'm going to just comment this part out here for a moment, and we'll run this again. And there are the slices that we got. From 2 to the end of the list gave us this. Up to 4, it actually gives us from 0 to index 3, right? Up to Kenny. -2 to the end of the list gives us Benny and Denny. And starting at 1, going to the end of the list, but skipping 1 gives us Penny, Kenny, and Denny. Here's number 1, 2, 3. That's why we got Penny, Kenny, and Denny. So it's pretty powerful technique that you can use with slicing. It takes a little while to get onto it because it's so it's a little different, that's for sure. But it's explained quite well in the textbook. So, any question about slicing? Okay, with why this program runs the way it does? All right, not hearing anything. I'm going to.
Oh, actually, I do have a question. I'm sorry. I don't know if I missed the part where we have the statement for BF in BFFS.
Right.
What is the assignment for BF? Like, where's that defined?
It's not. I just made it up.
Okay.
I just made it up. I could call it anything I want. I could use any variable name I want. Just that whatever I use, I have to put in here.
Okay, so it's just anything that is calling into the elements of that list.
That's right. Each element in the list, one by one, is going to be stored in this variable here as the list cycles. Yeah, as you go through the list, each element gets assigned to this variable.
Got it. Okay, thank you.
So this should work the same way with the with Buddy in there. Okay. Now I want to bring back this part, because this is about the in operator and its counterpart, the not in operator. In and not in, they're special keywords in Python, and they're excellent for lists. Here's the in operator. You notice it shows up in orange. That lets you know it's part of the language. So I'm going to see if Bonnie is in my pals list. The in and not in operators, they return a Boolean. In other words, they give you a true or a false. So this is going to print either true or false. Well, clearly, Bonnie is not in the pals list, so this should be false. If Kenny is in pals, that'll return true, right? If Kenny is in pals, if that's true, then we can say, yeah, we found him. Otherwise, Kenny's not found. And I'm sure you know about Kenny on South Park. So let's give this a run, see what happens here. Okay, there's the output I got. Yeah, we got a false here because Bonnie was not in the list of called pals, but we did find Kenny. We found him in the list. So Kenny was in pals. So that's a really powerful, very simple to use tool. I mean, it's like ordinary English, isn't it? If Kenny in pals, do something about it. In this case, say we found him. If I change this to, I'll just make another silly name here. Let's remember to change this back after, but we just change the name to anything else. Say, many's not found. Because many is not in the list. So this it becomes false, right? This if is false, so the else executes. And I'll just change that back to getting Kenny. Any question about that one? Slicing and the in and not in operator. Slicing is a little strange, but you can get, if you take a look at the book explains it very nicely. And I think I do have the ebook here. See if we can find where the slicing is handled. There it is. Starts on page 351. There's the concept right there. List name, start, colon, end. But the thing about the end is it's not including the end. It's one less than the end. Okay. Hope you're okay with that. By the way, I noticed something back there that we didn't cover, and that's that there's a repetition operator. A repetition operator that allows you to quickly make a list with all the values the same. So you could do something like this, for example. I'll just add it to the program that we were just working on. I'll kill this window off here first. And if I look at list 2 here, I could add a little something. I'll add it to the end. I could put here zeros equals, just put a 0 in there, times 10. And now if I print zeros, it'll do a crude dump, which is not something as a rule that we want to do, but that should dump out the list onto the screen. So I'll give this a run. And as you can see, I get 10 zeros. Whatever I put here, I'll get 10 of them. So I get 10 zeros. If I put in here 1, 2, 3 with comma separators, I'll run it again. I get 10 sets of 1, 2, 3. So that's another way that you can really quickly get a list in a specified way with the repetition operator. It's not really multiplication, it just means repeat when used with a list. Lists are such fun. They're a lot of fun to work with. I really get a buzz out of working with lists, and I hope you do too. Any question about this one at all? No? Okay. All right, well, we'll go on to the next one then. Kill this program off, and what we want to look at is one called list 3. Just fire that one up in idle. There it is. Now, here's something that you'll often want to do or have to do with a list. We might want to generate some random numbers. So I'm going to import the random module. I'm going to use an alias for it. I don't have to I could just say import random. Then when I wanted to use it, I'd have to say random dot. Well, if I'd like to simplify things, so I'm just going to let R represent the random module. That's called using an alias. And here's a technique for quickly getting a list of random numbers. What you do is you start off with an empty list. Nothing inside the square brackets. Creates an empty list called nums. Now I'm going to run a list. I'm going to run a loop 10 times. That'll run 10 times, as you know. Not even going to use that end variable, but I know this loop's going to run 10 times. And what I'm going to do is I'm going to use the append function. If you take a look at page 356 in your book, I'll just pop out there quickly right now. At the top of the page, on page 356, you'll see a list of methods. And I'm going to use the append method to add an item to the list. So let's see how that works then. Nums is the name of my list, nums.append. And what I want to append is a random integer. And I'm deciding to use random integers from 1 to 50 inclusive. So I've got r.randin. Notice I only have to use r here because I've got the alias up here. Otherwise, I'd have to say random.randin, which is okay too, but just trying to simplify it a little bit and show you that in case you hadn't seen it before. Now, that should generate a random list of 10 random numbers. I'm going to try another method that's back there in the textbook, the insert method. The insert method will insert a particular value at a particular index. So what we're going to do is we're going to insert at index 5 the value 75. And then we'll see what we've got in our nums list. So I'm going to just comment out the bottom part of this for a moment so we can concentrate on the top part. And let's see what we get here when we run this code. Okay, there's my random list. There's my random list. It generated 10 of them, but then I added another one. I inserted 75 at index 5. Let's see if that is in fact the case. There's 0, 1, 2, 3, 4. Yep, there it is at index 5. There's the 75. So the insert method, you can use that to add a value at any index you want. Notice all my random numbers are between 1 and 50. I could get a 1 and I could get a 50. Both 1 and 50 are included when you use randin. And we're printing them all out in one line. Now, another very interesting and useful method back here is the sort method. You can sort a list very quickly. Just use the name of the list and dot sort. So if we take a look at the code for that, I'll bring back these lines by uncommenting them. Okay, nums.sort, that'll sort the numbers. And we'll just print a little heading here, and then we'll go through the list again. This is an exact duplicate of the for loop I had up here. That should go through the loop, but they should, through the list, but they should now be sorted. There are other little functions that you can use with lists, like here's a min function, which will report the lowest number in the list. So let's run that whole thing again. Here we go. Okay, so there it is before sorting. Here it is after sorting. As you can see, everything is sorted from 3 all the way up to 75. And 75, of course, was the number that we added manually here with the insert method. So, of course, it's going to be the highest number because our randoms were from 1 to 50. And the lowest number is, in fact, a 3, as you can see also. Sorting helps us determine the lowest. By the way, after sorting, we could get the lowest just by saying nums square bracket 0, right? That would be another way of getting the lowest integer, because nums square bracket 0 is the first element in the list. So you wouldn't even have to use the min function if we've sorted the list. You can also, after sorting, you can reverse it. So you could, let's see, let's try. It's another one of these methods that's back there in the textbook. There's a reverse, reverses the order of the items in the list. So this should generate some interesting output. Let's try running that, making that change. Now they go from high to low. Reverse sort. So we sorted it twice. First from high to low, and then we reversed that. So now they're obviously from low to high. Or, pardon me, from high to low. Okay. Lists are fun. It's fun working with lists. And mainly that's because you've got loops to work with. Loops and lists go together. Any question about this one?
I have a good question on your, actually that line that you are right above. Well, actually the print, yeah, backslash, and is that right before the actual string? Is that to print in the following line, if I remember correctly?
Yes, that's it. Backslash n causes a new line.
Okay.
Yeah.
What is the difference? Because wouldn't that just print in the next line anyways, or it's because it's in the loop? In the for loop?
Well, watch what happens if I take it out. If I take it out, up here, we're not finishing the line.
Ah, okay.
Right? So watch what happens if I take it out. See the after sorting.
I see. Okay.
Yeah, it comes up here. So an alternative to putting the backslash n is you could just do a blank print. That would also finish the line. But knowing about backslash n is very useful. Okay, I'll just save that again. Any other questions about this one? By the way, there is a max function, which would also give you the highest number. So you've got these here. I didn't try remove, but that would remove a particular value. Like we could use the in. We could say if 32 in nums, remove 32. If we found it, like we could do something like that. It's unlikely that I would get that, I suppose, but we could use remove. We could remove any value at all. Now we know we've got 75 in there, so why don't I try that? That's what we'll do. I'll remove. I have to use the name of the list though. Nums dot. This is why we call them methods. Nums is actually an object, and objects can run methods. Methods are like functions that belong to an object. So if we go with remove, and what we want to remove is the 75. So it should be gone in this last printout, right? Let's see what happens if we try that. Yeah, no more 75. You can see that the list is shorter. So you've got lots of really interesting methods that you can use. And these are very well explained in the textbook, over 5 or 6 pages after this, by the way. And you will have to use some of these on your assignment. Any other questions about this one? No? Well, I've got just one more to show you. And it's called lists for. And here's what it looks like. Custom functions. You recall in chapter 5, we had to write our own custom functions. Functions that were not provided by Python, functions that we wrote to do some tasks that we wanted to do or that you had to do for your assignment. So what we've got in this particular case is I want to show you that you can use custom functions with lists, and it's very commonly done. You can pass a list into a function so that the function can process it, but a list can also return, a function can also return a list. So you can pass a list to a function so that it can be processed, or you can create a list inside of a function and have it returned. So that's what this first example is going to do, by the way. Here we have a custom function called makeList, and it's going to do its job and return a value into our list called nums. As you can see, I tend to use nums for numerical lists, but certainly you could call it anything at all. So let's take a look at the makeList function and see how it does its job. Well, here it is down here. The makeList function starts by making an empty list, and then it's going to start a loop that runs 12 times. And we're going to generate random numbers again. We imported random again as R up here. So we're going to generate random numbers between 100 and 200. Actually, between 100 and 201. So just to be between 100 and 200 inclusive, I don't need 201. It's not like the range operator. So 100 comma 200 should be fine. But after I generate that list by using append, I want to return it. So I've got a list called numbers. I'm going to return it. Well, what that does is it tosses it back to main. When that happens, when anything is returned by a function, you have to catch it in some way. Well, we're going to catch it in the assignment to the variable list called nums. So this will make the list. That runs all of this code down here, makes a list, tosses it back to main where it gets stored in this list name here. And then we could print that out. So what I'm going to do is I'm just going to comment out this second function for a moment. And we'll see if we do get, in fact, a 12 element, what looks like we're after 12 elements from 100 to 200. Should be in the nums list. Let's see what we get. Yeah, there's what I got. Looks like 12 of them, and they are all between 100 and 200. They're not sorted or anything. We could certainly sort them if we wanted to. But there it is. So this proves, this is an example of a function that returns a list. The entire list is generated inside this function and then tossed back to main. But remember, whenever you return a value, whether it's a single value or a list, you have to catch it in the main function in a variable. And then in this case, it's going to be in the list called nums. Now, we also have another custom function called listPlay. And this time we're going to pass a list into it. So you notice I've put parameters inside a single parameter inside the parentheses. Didn't have that up here with makeList. makeList did not require any parameter. But this one, we're going to pass a list into it so it can work on the list. It can do something with the list. So we have to pass it into the function called listPlay. And here's how we call it up here. I'll uncomment this. Bring that back. And because this function doesn't return a value, we don't have to catch anything. So we don't have any assignment operator to the left here. We don't have anything here, right? We don't need anything there. If we call a function, this is actually what you call a void function. It doesn't return anything. So this function, that will run the function right there. So when Python sees this line, it looks on the page to see if there's something called listPlay. And if it finds it, it runs all this code. Here's where we're passing the list into the listPlay function. In this case, it's called the argument. That's called the argument. Down here, it's going to be known as myList. I could have used the same name. I could have called it nums down here as well. But that might make you think that they're the same variable. They are not. This variable here is only known in main. this variable here is only going to be known inside this function. Variables are only known inside the functions in which they are declared, although parameters are always visible inside the function where they are specified inside the parentheses. They're always available. So what we're going to do is we're going to process the list of random numbers. What we're going to do is we're going to count the odds and the evens. So I'm going to create two counter variables, one for the odds, one for the evens. And counters are always initialized to a value of 0. Before you start counting something, the count is 0. I'm also going to use an accumulator variable called total, which whenever you're adding up numbers, before you start, the total is 0. So you always initialize accumulators to 0 as well. Now what we're going to do is we're going to go through the list for n in my list. Once again, I tend to use n for my numeric list, but that could be anything at all. I could use num, I could use x, anything at all. It's just that as I go through the list, each element is going to be known as n. Well, here's a test. This is a test for an odd number, isn't it? If the remainder when I divide by 2 equals 1, I know I have an odd number. And so I'll add 1 on to the odds variable. So that's where the counter is incrementing by 1. If it's not odd, it has to be even. So here we're going to, in the else block, we'll increment the evens variable. And the total is not in the if block or the else block. As you can see, it's not indented. So the total is going to go up by the value of the variable n. Accumulators don't go up by 1. They go up by the value of another variable, in this case, the n variable. And at the end of this function, we're just going to summarize what we found. And we'll add this max. We'll try the max function. See if that gives us the largest number. So all of this code is going to execute when we run this up in main. And it's going to use our nums list to process. So let's give it a run here. Okay, there's the output that I got. As you can see, we did get 12 numbers, all between 100 and 200. I didn't get any 100 or 200. Of course, that's going to run different every time I try it. I will try it again. There's the second piece of output. This time I did get a 100. And let's see, up here, the first time I ran it, I got 4 evens and 8 odds. So let's see, there's one even, there's another even, there's an even, there's an even, and the rest are odds. So, and of course, 4 plus 8 adds up to 12, so that looks pretty good. Apparently, they all add up to this value, and the largest was 193. Yeah, it looks like that is the largest. And when we tried it down, the second run down here, we get a totally different list of random numbers, of course. And we had 3 evens. Let's check that out. 100, 190, 170, and everything else is odd. Largest number? Yes, it is 199. So it worked okay. But the main point of this program was actually, the point is that a function can return a list, which is what this one did with the return statement. We made the list inside the makeList function. And a function can also take a list as a parameter and process that list internally in that function. And these, we've pretty much covered most of the skills I think you're going to need for your assignment. It's about what we want you to know about lists. Believe me, though, there is so much more you can learn about lists. Lists are just absolutely awesome to play with. You can do some really crazy things. Just as an example, I could make a list right here in the interactive window. I could say, we could just start using square bracket syntax, and I could say x for x in range maybe 100, comma 201. So that would analyze numbers from 100 to 200. If X percent 15 equals 0. So look at what I can do. I can use looping syntax and if syntax right inside the square brackets to make a list. And what this really means is let's make a list of variables called X if they're in this range and if they are exact multiples of 15, which is what this would mean, right? If X percent 15 equals 0, they should be exact multiples of 15. Well, let's see what I got. There they are. Those are all exact multiples of 15. This is what's called a list comprehension, which is an advanced list concept that we don't cover in the course, but I thought you might want to see how cool it is, and maybe that would get you excited about programming in Python. I'm done. I have nothing else for you folks. Any questions at all? Anything I could go over again?
No.
That's just the start of what you can do with the comprehension, by the way. You can do much more complex stuff than that. And you can Google list comprehensions and see some examples. Okay, well, I'm done then. Let's maybe just take a quick peek at the assignment. I think I've got it here. There's the practice assignment. Make sure you work these through. These are worth points. By the way, I'm a bit behind in grading these practice assignments, so I'll be getting that done in the next few days. That's a pretty good one. You have to create a function here called change list, which is going to take a slice. So it's got slicing in it. It's a very good example. Hope you enjoy that one. There's the output. You should get something like that. Of course, those are random numbers. And once you finish that, you get to see the solution. And here's the actual assignment. So you got 7-1, only one program. You only have to write one program here. But this one program covers almost everything you need to know about lists. You do have to make a function here. Oh, wow. I guess I gave that away in the example that we just did there, because you have to process the list and output the number of odd and even. Huh, kind of gave that away with that last example. My bad. I guess it was banging around inside my skull when I made up the example just before class. Well, I'm done then. Any questions, folks? No? Anything else I can help you with?
Nope.
Okay. I'm going to send you out something this week about the exact schedule for the exam. And I can give you as well some like sort of the example questions that I might give you on the exam as well. You're going to have to write little bits of code, like maybe 2 or 3 lines of code, like maybe something like stuff that we got in our program. Like how would you use a for loop to print the variables in a list called nums? So you'd be expected to type in something like this. Okay. Well, that's it then. All done. Last chance. Any more questions at all? No?
Nope.
Nope, none.
Okay. Well, this is being recorded. I'll get the recording up there as soon as I can. I hope you know that all of our lessons are available in the links and resources at the bottom of the table of contents. You will see all the videos that we've been doing on Monday nights. They're all here. And the new one on lists will appear at the top here when we're done. And I'll provide the examples as well. Okay. Keep working, keep busy, enjoy Python. Brad, out.
Thank you. Have a good one.